This is part A of our series introducing C++ in Unreal Engine, and today we are diving into 3 new classes of the first-person shooter template: the weapon component, the game mode, and the PlayerController Class. These are the pieces that tie gameplay, player input, and game rules together. So if you are ever wonder how the engine handles firing mechanics and player control at the C++ level, you are in the right place. Before we jump in, make sure to like, subscribe, and ring the bell so you never miss new content on creating video games in Unreal, learning technical skills, finding inspiration, and building a successful career in game development one step at a time, even beyond your daily job hours. And if you are serious about starting your journey as a game creator, visit the Game Creator Accelerator. It's designed to help you build your career in video games step by step with the right methodology, the skills to create your own games, and the strategies to build a die-hard fan base and to present yourself as a powerful asset any studio will want to have, all supported by lifetime mentorship access with me. You can also take our free training at woolen.com and start shaping your future in the industry today. Now let's get started and explore how the weapon component, game mode, and the player controller work together to power a first-person shooter in Unreal Engine. Let's start by opening the weapon component that it is on the first-person template of Unreal. The question is, what does this component actually do? In simple terms, the weapon component is in charge of the basic shooting mechanics. It handles things like spawning the projectiles, the bullets or whatever you are firing, which we covered in previous lessons, playing the sound effects when you shoot, and triggering animations like the recoil or the muzzle flashes. Think of it as the system that brings your gun to life in the game. This component connects what the player sees and hears with the action of firing a weapon. Now let's dive into the code and see how it works behind the scenes. Let's start with the header class. This class is called the UTP weapon component, and it inherits from the USkeletal mesh component. That means it's not just a regular object, it's a 3D model with bones and animations like a character or a gun. This class is what gives lives to the weapon visually and functionally. If not, the weapon will be just a static object. Let's remember some of the parameters defined in the U class. The blueprintable makes the class usable as a parent class for blueprints, and you can create blueprint subclasses based on this C++ class. The blueprint type allows variables of this class type to be exposed to blueprints. For example, if you have a U property with this class as a type, you can select it in the blueprints. The class group custom controls how the class is categorized in the add component menu in the Unreal editor. Custom creates a section called custom, and you can change it to something else, for example, rendering or AI. And the meta blueprint spawnable component adds special metadata, tells the editor that this component can be added dynamically in blueprints, for example, via add component in a blueprint actor. Without it, the component wouldn't appear as an option in the blueprint add component menu. Then we have our usual suspect, which is the generated body. In simple words, it's a spatial macro that Unreal Engine uses to insert all the hidden code needed for reflection, so the class can work with blueprints, serialization, garbage collection, to registering the class with the engine, and handling properties marked with U property and functions marked with U function. Think of it as in real ways to saying, plug in all the engine's internal wiring so this class can work with the editor blueprints and the Unreal runtime. And always remember that without it, your class would just be a plain C++ class without no connections to the Unreal Engine ecosystem. Now let's dive into the public section, starting with this projectile class. This tells the weapon what kind of projectile, that can be a bullet or energy ball, it should spawn when fired. It's editable in the blueprint editor, so you can easily swap to different projectile types. And we define it as a category of projectile. And the type will be a MyShooter FPS projectile, which is a projectile of another class that we define around here. This is the MyShooter FPS projectile. that you can also find here. Then we have the fire sound effect. This is the sound effect that plays when the weapon is fired. That could be a gunshot or a laser blast. To remember these settings in the U property, edit anywhere means that you can edit this fire sound inside the default class, or you can also do it on the instance of the class. And the blueprint read-write means that you can also do it in the event graph. Finally, we create another category for this type of variables. The next variable is called fire animation and is of the type UAnimMontage, which is an animation montage. An animation montage in Unreal is like a playlist of animations with extra controls. In simple words, it lets you play specific animations or parts of them whenever you want, like attacks, reloads, or special moves. You can break that animation into sections and jump between them, and you can add notifies to trigger sounds, effects, or code during that animation. Even though in this case we're using it for a weapon component, it is mainly used for characters' actions that are not part of the normal movement loop. For example, punching, climbing, reloading a weapon. So instead of just playing a looping walk-run animation, a montage lets you say, play this special animation now from start to finish and allow me to control exactly when and how it plays. Next, we have the muzzle offset. This is an F vector, and it provides a position offset that tells Unreal where to spawn the projectile in relation to the weapon, which is usually slightly forward from the muzzle. Next, we have two that are pretty related, which are the fire mapping context and this fire action. These two are related to the input handling. They connect the weapon to the player's input settings. In this case, the action that triggers the firing, like clicking the mouse or pressing a button on the gamepad. Next, we have the declaration of the constructor. This is for setting up the default values when the component is first created. Next, we have this function, the blueprint callable category weapon, which is the attach weapon of type Boolean. This function is used to attach the weapon to the character. It basically says, hey, you are now holding this weapon. And then we have the function fire, the key method that handles the firing logic. When the player presses the fire button, this function spawns the projectile, plays the sound, and trigger the animation. Next, we have what we call the cleanup logic. Look that here we are using the override over the function name and play. This is called when the component or the game ends. It is used for a cleanup, like disconnecting inputs or stopping animations. And finally, we have a private section where we have a variable called character. It helps the weapon know who it belongs to and where to spawn the projectile from. With this, we finish the header. Let's move to the implementation file. First, we have the constructor implementation, which is the UTP weapon component, and we defined the muzzle offset where the position is going to be. In this case, it's going to be a vector of the position 100, 0, 0. This is basically saying when the weapon fires, spawn the bullet a little in front and slightly above the weapon. Next, we have the fire function. The first thing we are going to do when we implement a function is checking that the objects or the variables that we need to call these functions are null. That's why at the beginning, we first confirm that the character is null and also that the character getController is null. If that's the case, or one of them is null, then we return. We stop the execution of this function. If everything is okay, then we move to the spawning a bullet or a projectile. The first F is confirming if we have something to shoot. This checks whether a projectile like a bullet or a rocket has been assigned to this weapon. Then we check the world. This provides us with the current world, for example, the game level, the environment we are in, because we need it in order to spawn new actors like projectiles. These actors will be part of this world, and this is why we check what this world is. Next, we create a variable inside the function to collect the information about the character controller. Look that the type is a player character controller, and we are getting the player controller from the character. We know that we can do that because we confirmed that condition at the beginning. With the spawn rotation, we get the direction the player is looking, which is the player camera manager camera rotation. So we can shoot forward from the perspective of the player, the perspective of the camera. Then we are going to create or calculate the starting position of the bullet. With this line of code, we first get the position of the weapon's owners, which is usually the character or the gun, the weapon that you're using. Then we add an offset that we already calculated, which is the muzzle offset, to move the bullet forward so it doesn't spawn inside the weapon. It could be also inside the character, but in this case would be inside the weapon. And then we use the spawn rotation to make sure that the offset is based on where the player is looking. Next, we create a new variable based on a struct to handle specific settings for how to handle the collision of this weapon with other objects. This tells Unreal how to handle spawning if something like a wall is in the way. It tries to adjust the spawn location slightly to avoid overlapping, but if it can't, it just won't spawn the projectile. This section is more like a safety feature in the process of spawning a projectile. Finally, we get to the spawning of this projectile. This line creates the projectile in the world at the right location and angle. In the world, we use the function spawn actor of the type MyShooterFPS projectile, and we pass the parameters of the projectile, the location, the rotation, and the actor spawn parameters that we define here. The 4 parameters presented here belongs to the spawn actor function. As you can see in the details, you have a U class for the first parameter, which will be the projectile class, then a constant, which is the vector for the location, another constant for the rotation, and finally an F actor spawn parameter. The next section is related to the fire sound. The first thing we check on the fire sound is that it is not null. We need to confirm that we set this variable. Once we define that this variable is set, then we play the sound at a specific location. To call the play sound at the location, we use the uGameplay statics. In simple terms, the uGameplay static is Unreal Toolbox for frequently used gameplay actions like spawning, playing sounds, and getting reference to the player or the world. Examples of code that we usually use with uGameplay statics is to play a sound like this one, also to spawn an actor, and in that case you use the spawn emitter at location, and also to get the player character, and in that case you use the uGameplay statics get player character. Now let's move to the fire animation. As usual, we first check that the fire animation is not null. Then we defined an anim instance of the type uAnimation instance. For that, we are going to use the character that we defined previously in our header, which is of the type MyShooterFPS character, and in that we'll look for the getMesh1p and getAnimation instance. Just to remember from all the lessons, let's go back to Unreal, and inside the blueprints on the folder blueprints, open the blueprint first person, which is the character that we use to play with our game. Inside that character, we have a component which is called the Mesh1p. That's why in the code, we're looking for in characters the getMesh1p. And inside the getMesh1p, we're looking for get the animation instance. The animation instance of the player is what we're going to use to execute one of the animations. Now, you can go to the animation class in the one player. Let's open this one and the blueprint, and you will see that even though we have several animations and state machines for weapons, for carrying the weapon or not, in this case locomotion rifle state machine, if you get inside, you won't see anything related to the animation of shooting. So where is the shooting animation? The answer is pretty simple and is, let's go back to the code. Remember that the fire animation is set on the TP weapon component. So if we go to the Unreal and look in the first person blueprints, the BP pickup rifle, you select the TP weapon and look for animations, and here you find the fire animation. And if you inspect this animation, let's open it, you will see that is an animation of shooting. Back in the code, you have the anim instance, and then you play the montage, because look that in this section is defined as animation montage, and you called that inside, which is the fire animation, and the 1.f means that it plays at a normal speed. In simple words, what this fire does is, one, make sure that everything is set up, like the character, controller, projectile class. Then it figures out where and which direction the bullet should spawn, then spawn the projectile, then play a shooting sound, and finally play a shooting animation. But we have nothing to shoot if we don't attach this weapon. So let's start with the attach weapon. We first start by getting the character, which is the target character that we pass in as a parameter in the call of this function. Then we check if the character is null. If it's null, immediately we return false. And also we check that the character already don't have a UTP weapon component attached. Because if the character already have one component attached, we don't want to attach another one, not at least for this template of Unreal. That's why if we find something attached, we return false. Continuing with the code, we have the section where we attach the weapon to the character. The first line, which is the F attachment transformation, has several parts. The attachment transform rules defines how the weapon's position, rotation, and scale should behave when it is attached. The deattachment rule, snap to target, means when the weapon attaches, its location, rotation, and scale will snap exactly to the target's socket or the bone transform. And the second parameter, which is true, means that the weapon has physics enables. It will be held its physics body to the parent, acting as one combined object. Now let's go back for a second to the first parameter, and you might be asking yourself, what do you mean with sockets or bones? Where is this located in the character? If you go to Unreal, and let's open this most recent animation montage that we opened a second ago, you can go to the skeleton, and inside that skeleton, find the socket where you're going to attach this weapon. In the code, you can find that the socket will be called grip point. So let's look here, grip point. And if you click, you can see that we have a socket which is located very close to the right hand, which makes sense because it's the base location for this weapon. And what is saying with this code, what we're saying with this code is that we are going to attach to that socket. That's the other part, which is the other line of code. In this line, we are executing the attaching process. The first parameter, which is the character mesh 1p, gets the first person's arm mesh of the character, and the weapon will attach to this skeletal mesh, the one that I showed you a second ago. Then we have the attachment rules that we defined in the previous line, and then we specify the name of the socket where we're going to attach this weapon. Next, we add this weapon as an instance component to the character. Remember that initially, if we go to the character, open here, the BP first person character, initially we don't have any weapon. But with this line of code, we are attaching that component to that character, to that first person character. Next, we get into set up the bindings. The first thing is to check that we have a player controller of the type A player controller. Look that we cast the character get controller as a player controller. And if that's the case, then we can proceed. Then in this if, what we do is retrieves the uLocalPlayer object for this controller. This exists only for players that are actually running locally, not AI characters. The U local player subsystem enhance input local player subsystem tries to get the enhance input subsystem tied to that local player. This subsystems manages the enhance input system, which is the new input mapping systems in Unreal Engine that allow us to take control of the characters. And then we pass the player controller that we confirmed a second ago, the get local player, and confirm that this is not null. If that's the case, then we're going to add a new mapping called the fire mapping context. You probably remember that inside our project, we have an input and we have two maps, one without the weapon and one with the weapon. And if we go to the BP pickup rifle and in the TP weapon you look for map, then you will find that we are using exactly this new map, a map that will work for using the weapon. And this is the parameter fire mapping context that you can find here when we call the subsystem add mapping context fire mapping context. So we are adding a new feature for a new action for the mapping context that we already have. And finally, we get to add this action. This is the last part of this if. First, we confirm that we have an enhanced input component. That shouldn't be a problem for this point because we already have it. And then we add this new action, which is the fire action. If you go to Unreal and look the actions, you will find a fire action is not called exactly fire, it is called action shoot. And if you open as well the BP pickup rifle and look for the action, you can find the fire action called IA shoot, which is exactly this one. And finally, when we finish this execution, we return true for this function. Now let's go to the final function, which is the cleaning. This end play function. This function is called automatically by Unreal when the component is being removed, destroyed, or when the level game ends. The first section is pretty straightforward. We check that the character is null pointer, and if that's the case, we return. That means there is nothing to destroy. If, in the other case, there's something to destroy, what we're going to remove is the mapping context. And for that, to get that mapping context, we're going to first pick the player controller that you are going to cast it as a player controller from the character get controller. Then we're going to check the subsystem and we're going to recover it just the same way that as we did before. And finally, from that subsystem, we're going to say remove mapping context and pass the name of the mapping. In simple words, when the weapon is removed or the game ends, this function is called. It removes the fire button mapping that was previously set up, and this ensures that no dangling input bindings are left after the weapon is gone. Now let's get back to Unreal to explain other two important classes. Let's start with My Shooter FPS Game Mode. When you click on the world settings, you have a parameter that is called the Game Mode Override. If you click here, you will see that the blueprint that we use for the game mode is this one called the BP First Person Game Mode. If you open it, you will find as well that we have some classes that are defined for several things in the video game. One of them are the player controller, the HUD, the default spawn, and so on. And if we inspect the class setting, you will see that we are using the My Shooter FPS Game Mode, which is the one that is here. You can set the game mode that you will use, and you can also define here the default pawn class, the HUD, the player control class, and so on. Now let's open this class. This is a very straightforward class of the type game mode base. As you can see, we only have the generate body and a constructor for the class, all in the header. If we go to the implementation folder, you have only the definition of the constructor. And in it, you are telling Unreal which character pawn should be used when the game begins. This first line is looking in your content browser for a blueprint class, your character blueprint class. And as you can see, here is the parameter. It is in game first person blueprints BP first person character. It uses the F class finder to load the blueprint class at that path and confirm it is of the kind A pawn. Finally, now that we found the player pawn class finder, we assigned that to the default pawn class. The default pawn class is a protected property defined in the GameMode base. If you want to know more, you can get over it, right-click, and select Pick Definition. And here you can see the default pawn class that is part of the GameMode base. In summary, this constructor tells Unreal Engine, when the game starts, use my custom first-person character blueprints as the player's pawn. It's a small but a very important part to setting up the game. Without this, Unreal wouldn't know which character to spawn for the player. And then we have the player controller. And just as the previous one, if you go to the BP and select the BP first person player and select the class setting, you will see that we are using the FPS player controller. Let's open it. In the header file, well, we have a new class which is of the type A player controller or player controller. Inside the class, we have a protected variable called the input mapping context or the input mapping context, which allows us to have control, define what is going to be the keys and the actions associated with these keys. And finally, we have an override for begin play. Back to the implementation, we find the begin play starting with the super begin play because we are overriding a class. And then we first confirm that we have a subsystem. This line is doing two things. It gets a reference to the enhanced input subsystem tied to this player, and that subsystem is responsible for managing modern input features like the multiple control schemes, mapping context, and enhanced input actions. Check that we are using the local player and we're getting the information from the local player here in the get local player. So it's the subsystem associated to the local player. In other words, this line is just saying get the input system for this player if it exists. Then, if that subsystem is found, this line adds your custom input mapping to it. The second parameter, this 0, is the priority level. Lower numbers means higher priorities, so this context takes top priority for input detection. It's like saying, apply this control scheme for this player right now and make it the primary one. When the game starts this function, this first ensures that the base begin play runs, then finds the enhanced input system for this player, and then it loads your custom input settings so your game knows how to interpret player controllers. And with that, we wrap up this playlist where we introduce C++ for Unreal Engine. This is the last video of the series, but it's really just the beginning. With your support, by showing me that you enjoy this content, we'll take the next step together, building a complete third-person character video game project line by line inside Unreal Engine. At the same time, I'm expanding the courses I've already created on Udemy to become part of the Game Creator Accelerator. The GCA is not just about learning Unreal Engine technical skills, it's also about creating a plan to grow your career, even in market conditions that are challenging. In fact, those same challenges are opening up some of the most interesting opportunities we've seen in years. And if you are ready to start shaping your own path, check out the Game Creator Accelerator. This program is transforming the lives of new talents in the gaming industry one step and 1 hour at a time. It is designed for people balancing daily jobs, family, and responsibilities while still wanting to break into the game development. Inside the GCA, you will find not only the Unreal Engine skills you need, but also the guidance to build routines, set a solid career plan, and turn limited free time into consistent progress towards your dream. Take our free training and start building your future in games today. So don't forget to hit that like button, subscribe, and ring the bell so you never miss new content on creating video games in Unreal, developing technical skills, finding inspiration, and learning strategies to build a successful career in the industry, one step at a time, even beyond your daily jobs. As always, keep creating, keep sharing, and most importantly, keep dreaming big. See you soon, my fellow creators.